Okay, so today we're going to talk about, extend our discussion of lines a little bit. We're going to talk about, why don't you click everything closed, please? Yes. You betcha. It's, yes, there you go. Actually, I think it's just the back of page 1. There you go. Thank you. Anybody else? Good? Okay. So we're gonna talk about kind of slope stuff. We're going to talk about determining if lines are parallel or perpendicular or neither. That's sort of our first topic. We're going to talk about how to find intercepts and then how we could use the intercepts, the X and Y intercepts, to graph lines. So not a ton on the docket. All right, so first of all, horizontal and vertical lines. Okay, so let's take a vertical line as an example. We've got a vertical red line. I've plotted 3 ordered pairs corresponding to points on the line. What do you notice here about those 3 ordered pairs that sticks out? Yes, sir. Grant. The X values are all the same, right? The Y values are going to change, but the X values are all the same. And because the X values are all the same, and the Y could be anything, right? How are we going to name this line? We name it based on its X value, because that's the thing that's the same every time. So the equation of this line is just X equals -3, right? Everybody see that connection? Okay. All right, same experiment with a horizontal line. What do you notice about the horizontal line? Yeah, the Y coordinates are always the same. X could be anything, but the Y is always equal to 1. And so we name that Y equals 1, okay? And that's always how we deal with horizontal and vertical lines. Vertical lines are always named by their X coordinates, and horizontal lines are always named by their Y coordinates. If you want an easy way to remember that, just think about where they intersect an axis. Where does a vertical line intersect an axis? At X equals 3, right? Where does a horizontal, in this case, right? Where does a horizontal line intersect an axis? Well, a horizontal line only intersects the Y-axis, and it intersects it at Y equals 1. Okay? All right. So, parallel versus perpendicular. Okay, can you guys remind me from earlier, Algebra 1 probably last year too, what's the relationship between the slopes of parallel lines? Slopes of parallel lines. What do you think, Sydney? So parallel lines, their slopes would have to be what? The same, yeah. Good, they're equal, aren't they? Right? They'd have to be too. If they weren't the same, then ants would rise and would rise and run by different amounts, and eventually those lines would cross, wouldn't they? Right? So, yeah. Slopes of parallel lines are equal. Now, this is a little trickier. The slopes of perpendicular lines, do you remember how they are related? There's 2 parts to this. So they look like this, right? They're crossing at right angles, but what's true about their slopes? They're opposite. What else? They are opposite signs. What else? Think you got it? Grant, go ahead. Say it again. Yeah, you got it. Reciprocals. Yep, exactly. That's it. Perfect. They are opposite reciprocals. So we got to change the sign and flip the fraction. Okay? So we can use that information to determine if 2 lines are parallel or perpendicular, or if neither one of those 2 things is happening, then they're neither one of them, right? They're neither parallel nor perpendicular. So let's try an example. Let's try, let me see, is that? Yeah, there we go. So let's try this example right here. We've got these 2 lines. What do we need to find out about those lines to determine if they're parallel or perpendicular or neither? Slope matches up, right? We have to know the slopes. That's all we need, though. Do we need anything else about the lines? No. Parallelism and perpendicularism, that's exclusively based on the slopes of the lines. We don't care anything about Y-intercepts or any of that stuff, right? We just care about slopes. So let's deal with both of these lines. Let's make this one, we'll call this the red line. Okay, so we're starting here with 10x plus 5y equals 5. Now, how are we going to find the slope? Say it again. Subtract the 10x, okay. Okay, and where are you going with this? You're right. What's the strategy here? Yes, ma'am. There you go, y equals mx plus b, right? Good, we're trying to put this into the form y equals mx plus b. And we know that the coefficient of x is the slope, right? So that's all we got to do is put it into slope-intercept form. As we discussed a couple days ago, all that means is isolating y and simplifying, right? To put an equation into slope-intercept form, a linear equation, we just isolate the y on one side and simplify the other side. So what are the steps then? Good. So Roper got us started on the right track here. We're going to subtract 10x from both sides, right? And that's going to give us 5y. Here, I'm going to scoot this over a little bit. 5y equals, now I want to put the x term first, don't I? Yeah. Right? Negative 10x plus 5. Then we divide by 5. Good. Okay, and dividing by 5 means that we're going to divide the whole side by 5, so we can split that and divide each separately. Agreed? Yeah. Okay, and then what do we get when we do that? So we get, now this is important too, so everybody pay close attention to this because you're going to see something that's going to save you some work. I get negative 10 over 5 is negative 2x plus, who cares? I don't care, right? We don't care what, all we care about is the slope. So we really could stop here and we're good. Okay, everybody get the idea? Okay, so now we're going to deal with the other line. So we'll make this our blue line, how about? Okay, so here we've got negative x equals 2y plus 16. Okay, does the y have to be on the left side? No, we could just solve it, isolate it on the right side too, couldn't we? And then flip it around, right? And then just exchange sides maybe. So what are the steps going to be there to get that y by itself? Okay, subtract 16, all right. Okay, so that's going to give us 2y equals negative x minus 16. And I'm going to flip it around. I'm going to put the y over here. So we get 2y equals negative x minus 16. Last step, divide by 2. And we get y equals, what's my slope going to be? Close. Negative 1/2. Negative 1/2 x plus, we don't care, right? All we care about is just this guy right here. So m equals negative 1/2. So there are my two slopes. Now you tell me, based on those two slopes, thumbs up or thumbs down, are the lines perpendicular? Ah, you caught it. This is a good group. You caught it. They're reciprocals, but what are they not? They're not opposites. They're both negative, right? So one of these would have had to be positive for these to be perpendicular, right? Okay? So let's make a little note of that. Slopes are reciprocal. Can't spell. But not opposite. So they are neither. Say it again. Okay, that still wouldn't work because they have to be opposite and reciprocal. They have to be the flips of each other and opposite. Yep. Yeah, or negative 2 and positive 1/2, or positive 2/3 and negative 3/2. Say it again. Because what's the reciprocal of negative 2? Negative 1/2, right? That's the reciprocal. I'm just flipping the fraction, right? That's all we're doing. That's all reciprocal means, is to flip the fraction. But they also have to be opposite signs. Okay, let's try another one. How about those two? Okay. So here, this will be our red equation up here. Now, I would claim that you can almost, let's go back to this last slide. I would say you can almost do this in your head, because it's only 2 steps, right? Like if I'm trying to solve for the y here, I'm going to subtract the 10x and divide by 5, and negative 10 divided by 5 is negative. You can almost just do that in your head. You know what I mean? Like you can almost just isolate that y and determine what the coefficient of x is going to be. After you've done 5 or 10 of these, you'll probably start to say, oh, this takes too long. I can do this in my head, right? And that's okay. What about this one? If I want to solve for y there, let's do this in 1 step. We'll write it down, but let's do it in 1 step. What am I going to get on the other side if I isolate that y? Well, I'm going to get a negative 9x minus, who cares really, right? Divided by negative 6, and we don't even really care about that one. So what's the slope going to be then? If I combine those, what's negative 9 over negative 6? 3 over 2. Good. And so that's the coefficient of x, right? So we're going to get y equals 3/2 x plus, we don't even care, right? There's our slope. Okay, give me thumbs up, down, sideways. How are we doing? Okay. How about the blue line? Here's our blue line. If I isolate the y, what am I going to get on the other side? Minus, who cares, right? All we care about is the x term. Yeah, so then I'm getting y equals negative 2/3, because positive over negative is negative, right? Negative 2/3 x plus, we don't care. And look at those two. Yeah, those are opposite reciprocals, so they are perpendicular. Okay, everybody good with that? Okay. All right, so next issue then. Okay, X and Y intercepts. Now let's take a look at something here. We've got this line graphed. Let's identify where the X and Y intercepts are. So the X-intercept is here. The X-intercept is at that point right there, and notice what the coordinates are. The coordinates are negative 3, 0, right? The Y-intercept is at this point right here, and its coordinates are 0, 4. Okay, what's of obvious importance there to us, maybe? Anybody see that? That's important, right? The x-coordinate of the y-intercept is 0, and the y-coordinate of the x-intercept is 0, right? Everybody get that? It has to be that way, doesn't it? Because think what an x-intercept is. An x-intercept is where a line crosses the x-axis. Well, every point on the x-axis has to have a y-coordinate of 0, doesn't it? To be on the x-axis. It can't be up or down at all, right? The y-intercept is where the line crosses the y-axis, and every point on the y-axis can't be left or right at all from its starting place at the origin. So it's got to have an x-coordinate of 0. So that gives us a recipe here, right? If we want to find the x-intercept of an equation, like we have right here, for example, then what could we do? What's happening always at the x-intercept? At the x-intercept, what's happening? y is always equal to 0, isn't it? Right? The y-coordinate is always 0. So here's our strategy. If we're trying to find the x-intercept, all we have to do is set y equal to 0 and solve the equation for x. Okay? That's it. That's it every time. Think what that's doing. Like if I take this equation down here, for example, if I want to find the x-intercept, I'm setting y equal to 0, so the left side of that equation is becoming 0. Agreed? So I end up with the equation 0 equals 2x plus 50. What are the two steps in order to isolate the x? Subtract 50 and what do you get if you do those two things? Negative 25. Okay? Pretty easy, right? Okay, there's a little trick I'm going to show you. This is called the Heaviside cover-up method, but you don't have to know that. Just think of it as Mr. Oya's cover-up trick. So all you have to do here is use your hand or your finger if it's on paper. If I've got a linear equation and I want to find the x-intercept, all you have to do is cover up the y term, because if I set y equal to 0, that term's going to go away. It's going to be 0, and solve for x in your head. Subtract 50 and divide by 2, and I get negative 25. How about that? Okay. What about the strategy for finding the y-intercept? What's that obviously going to be? Set x equal to 0 and solve for y, right? Same idea. Set x equal to 0 and solve for y. Let's try that one. So if we start with our original equation again here. Y equals 2x plus 50. If I set x equal to 0, I get y equals 2 times 0 plus 50. What's 2 times 0? 0. So I just get y equals 50, right? I can use the same trick. I just cover up the x term, because it's going to go to 0 when I set x equal to 0. 0 times anything is 0, right? And solve the rest. Well, that's pretty easy. It's already solved. Y equals 50. Done. Okay? Good little trick, huh? Okay, very easy to do. Okay, why do we do that? Well, we need to find intercepts for a variety of reasons, but if we're trying to graph a line, how many points do we need to graph a line? 2. That's it, right? I make 2 points, connect and extend, done. So if my 2 points could just be the intercepts, if I didn't have a graph of this line up here, for example, but I could find where the intercepts were, I could make the graph by connecting and extending. So it's a good, easy strategy for graphing a line. Okay? All right, so just a couple of vocabulary things. Not a big deal at all. Just put these on your notes, though. So x-intercept is what we call this point right here when we're focusing on the fact that it is the x-intercept. We're trying to find where the line crosses the x-axis. But there are some other words. We do this a lot in math, right? There's some other words that essentially mean the same thing. Like we could call it a root or a zero or a solution to the equation. And later on in the class, we'll kind of gradually start to use these other words, and you'll sort of see why. I mean, there's a little flavor that each one has that's different than the others, depending on the context, right? It's like, again, I'm going to go back to, do you use interval notation or do you use inequalities? They give you the same answer, but sometimes there's a preference. There's a preference. Sometimes it makes more sense to use interval notation. Sometimes we'd rather use inequalities. They do the same thing. They're just slightly different. One has a slight advantage in some ways and not in others. So that's why we do this stuff in math. Okay, let's practice this intercept stuff. Let's try this cover-up trick and see if we can graph this line by using the intercepts. Okay? So let's take this top line up here. It's in standard form. 5x minus 6y equals 30. Let's see if we can find the intercept. So let's find the x-intercept first. Okay, I'm going to write the ordered pair. What can I already fill in on the x-intercept? I already know one of the coordinates of the x-intercept. What's that? Say it a little louder. Before I even do anything, I know what one of those two, y is 0, guaranteed, right? So we know y is 0, so then how could I solve for x? Which term am I going to cover up in that equation? I've got my equation 5x minus 6y equals 30, but if I know that y equals 0, whoops, if I know that y equals 0, what term could I cover up? Yeah, the y term, right? Because 6 times y is just going to be 0. Subtracting 0 doesn't change anything, right? So we could just do this, right? We could just take your finger or your hand or something. Oh, what happened there? Yikes, there we go. So now, if I solve that equation, I can do that in my head. So can you. What's x equal to? 6. Just divide both sides by 5 and I get x equals 6, don't I? Okay, so we can fill that in. So I've got the point on my graph at 6, 0. So 1, 2, 3, 4, 5, 6. There it is. Y is 0, of course. How about the y-intercept? I know one of those coordinates already. Which one do I know? X is 0. So which term, Michaela, which term do I get to cover up this time? X. There you go. Set the x term equal to 0. And I get negative 6y equals 30. So what's my answer? Negative 5. Now how easy is that? That's a pretty good deal, huh? So 0, negative 5, 1, 2, 3, 4, 5. There it is. And now we can draw our line. We'll just connect and extend, and there it is. Okay? We can do this, you know. Okay, here's another example. Let's just look at this one. This one's already filled in on your notes, but let's just go through the steps on this. So if I want to find the x-intercept, I'm just going to cover up the x term and solve, right? And I get y equals 2. Okay? Well, I guess we did that one. So there's the x, or the y-intercept, sorry. I said x-intercept, y-intercept. Cover up x, because I'm setting x equal to 0, and I get the y-intercept 0, 2. Okay, so there it is. Zero, 2 is right there. Okay, what about the other one? If I want to find the x-intercept, I'm going to cover up y, right? And what's that leave me with? That leaves me with a little tougher equation, doesn't it? I've got to subtract 2 to the other side, right? So I end up getting the equation, if I cover up the y and solve, I get negative 6/5 x equals, on the other side, I've got negative 2. Okay, so the step I want to just talk about for a second is, how do I isolate the x? Remind me, how do I undo multiplying by negative 6/5? Just any fraction. What do I multiply by? The reciprocal, right? To undo multiplying by a fraction, rather than dividing by the fraction, we always multiply by its reciprocal. It's way easier. So I'm going to multiply both sides by negative 5, 6. Okay, everybody good? That's going to cancel out that fraction, and so I get x by itself. Negative times negative is positive. If I multiply straight across, I get 2 times 5 is 10, divided by 6 is 10/6, which I could simplify to what, 5/3? Everybody good? Okay. We could also do that by clearing fractions if we want to, like they did up here, right? We set y equal to 0, and then we multiplied both sides. We distributed a 5 through, right? That's really all we did there. Let's just show this step. When I distribute the 5, 5 times 0 is 0. The 5's cancel here, don't they? I get negative 30 over 5, which is negative 6, and then 5 times 2 is 10. So you can do it that way too. You can clear fractions like we've done in the past also. It's okay. Either way, I'm going to end up getting 10/6, which reduces to 5/3. Okay, so if we graph that point, that's a little harder to graph. We get the point 5/3. Now, what is 5/3 as a mixed number? Because to graph it, we probably want to know. 1 2/3, because 3 divides into 5 one time evenly, with 2 remaining over the 3, right? So 1 2/3, that puts us out about right there. Okay? Everybody good with that? Okay, with this one, was there maybe an easier way to graph this one? Look at the original equation. I'll tell you what, I would not have used intercepts to graph this one. What would you probably have done on this one? Y equals negative 6/5 x plus 2. Probably start at 2, right? And then just use a slope triangle and create a second point that way. Everybody get that? If I use this slope triangle, here's my slope, right? There's my y-intercept of 2. If I use the slope triangle of negative 6/5, that means I'm rising by negative 6 and running by 5, right? So I would just rise by, there's 2, 4, 6, negative 6, and I'm going to run by 5. And look what that does. That gets me to a more convenient spot that's easier to graph, doesn't it? Everybody see that? Okay, so intercept method worked here, but was it really the best? No, not really. I mean, probably be easier just to graph it using slope-intercept. Okay? All right. Let's skip down to number 4. You guys do this one real quick. When are we out of here? Okay. Let's see how many more. That one we need to do. Yeah, let's do, you guys do that one really quick, number 4. Yep. Oh, was that just delivered? Oh, I got you. Okay. Gotcha. Okay. Oh, this is like, what is it? Oh, that's fine. Yeah. Okay. You're good. All right. So try this one real fast. Hey, I'll tell you what, really quick, everybody grab why don't you grab one of these boards? So you can do it on this and just hold it up so I can see what everybody's doing. And then here are pens. This has been this is kind of a nice little, I repurposed this, nice little pen. What do we call this, a pen caddy? That's what I'm calling it, my pen caddy. You're good then. But what'd you get for your X-intercept? It's 2, yep. What's your Y-intercept? You got it. So really what I just want to know is what's your X-intercept and what's your Y-intercept? Say it again. You mean the Y-intercept, you mean, right? No, the X-intercept is what I get when I cover up the Y and solve for X, right? The Y-intercept is what I get when I cover up the X and solve for Y. Okay, so my X-intercept, what term am I covering up? The Y term. What do I get? 4x equals 8. So X is what? 2. You got it. So X is 2 and Y is 0, right? Okay, what about the Y-intercept? Let's see. X is 0, so I'm covering up that X term, and then I get negative Y equals 8. So what's Y? Negative 8. Excellent. So in this case, X is 0, Y is negative 8. We can graph those two things. And there is our line. Okay, good. All right, so how about one more? And I think this would be enough. Let's see. Yep, that's it. Okay. Number 6. Now, what am I going to do? Everybody think about this for a second. What do I definitely want to do here before I even start on this problem? Yeah, clear the fractions. Good. Okay, so go. Clear the fractions and find the x and y intercepts for me. What am I multiplying by? 12. Okay, when you're done, let me see what you got. Hold up your answers. Let me see what you got. Yep. And you'd reduce. Did you reduce that top one? You could though, right? Yeah. What's that? The top one. You got. Was that 24/9 you had there? Maybe I didn't see it right. Oh, 20. Oh, okay, yeah, right. So that one you already saw you reduced that one, right? That one's. Right. Okay. Yeah. So. Okay. Good. Good. But remember, we got a little shortcut here. Remember, we can just do this. If I want to find the x-intercept, I can just cover up, set y equal to 0 and solve. So I'm just getting negative 24/9, right?
Yeah.
Which I could reduce. If I want to find the y-intercept, I'm just covering up that term. Get negative 20, just divide both sides by negative 4. See what I'm saying?
Yeah.
Okay. How you doing on this? Good? Yeah. That looks good. What'd you get for that one, though? That one's a little goofy. Oh, oh, yeah, okay, yeah, it wouldn't be 12 there, would it? It'd be 4, right? You think you got a 12y. Okay, you're making too much work, though, right? If I want to find the y-intercept, all I've got to do is cover up the x term and solve. But on the other side, you forgot to distribute. I see what happened. So when you distribute that 12, you have to multiply the 12 times the negative 2 also, so that should be a negative 24. See what I'm saying? And, okay, try that. That's correct. Yep. Okay. You good with this? Okay. Okay, let's see what you got. Because you can just use that cover-up. You don't have to do any of that stuff. You can just use the cover-up method, right?
Oh, okay.
Yeah, just use that cover-up method. What you get, Megan? Excellent. Excellent. What do you got, Sean? There you go. Negative 8 thirds. Perfect. Okay. Okay. Good. Good. Okay. All right. Hey, let's take a quick look, everybody. So it looks like everyone's basically on the right track here, even if they haven't totally finished. Some people made this a little tougher than they needed to, though, right? Now let's look at these simple steps. Phones away. Focus up here. Okay, so first step is clear fractions, right? I'm going to multiply through by 12. 12 times 3 is 36. 36 over 4 is 9, right? Or use my trick, my patented trick. And 12 over 4 reduces to 3, which I multiply by 3 to get 9. Either way, we get 9x here. Here we're going to get 12 over 3 is 4, so we have minus 4y. And don't forget to distribute the 12 to the other side also, and I get negative 24. So there's my simplified standard form equation, right? Now to find the intercepts. Well, to find the x-intercept, a bunch of people were trying to isolate y, right? Solving for y. We don't have to do that. Use the cover-up trick here. Super easy. If I want to find the x-intercept, what am I setting equal to 0? Y. So that's an easy way to remember this. If I want to find the x-intercept, I'm just going to cover up the y term and solve for x, right? I'm trying to solve for x to find the x-intercept. Does that make sense? So if I cover up the y term and solve for x, what do I get? 9x equals negative 24, so x equals negative 24 over 9. Agreed? Okay, so negative 24 over 9. I could reduce that, though. I could divide 3 into both of those and get negative 8 thirds, right? Okay. So I can draw my x-intercept. Negative 8 thirds is what? Negative 2 2/3. So I'll go back. 1, 2 2/3 is right about there. How about the y? I'm going to cover up the x term now. Negative 4y equals negative 24. I divide negative 24 by negative 4, and I just get 6, right? I got negative 8 thirds, and negative 8 thirds is equal to, as a mixed number, 3 goes into 8 2 times with 2 remaining over the 3. So negative 2 2/3 is where I had to put that, right? Yeah, we don't use mixed numbers except to graph things. When I need to know negative 8 thirds, it's hard to know where that is on the number line. So I think of it as a mixed number. You say it again? Okay. Okay. Yeah, I got you. That. Okay. Well, okay, so we get 6. Y is 6. 1, 2, 3, 4, 5, 6. So it's right there, right? Okay, so then this should be my line. Okay, so then, right, so on this one, okay, so you're doing it a different way though, but we can use the intercept trick on this one. Use the cover-up trick, right? Cover up the x and solve for y. Cover up the y and solve for x, and it's way easier. It's much less algebra to do.